So all substances and everything you see around you is made up of things we call atoms. So essentially what that means is that if you were to take any substance and you're zooming in over here, what you notice is that you have loads and loads of atoms grouped together which make up that matter. Okay, so this is your atom. And actually, depending on the material and the specific type of substance that you're looking at, that atom can look slightly different. So you can get different types of atoms, or the structure is slightly different. And we'll look in a bit more detail what the structure of an atom looks like and how atoms vary. But essentially, what happens is you get different types of atoms, and essentially this is where we get different types of elements. So when you have different types of atoms, this is what you end up with, a different type of element. So for example, you could have an atom of oxygen or an atom of sodium. So oxygen and sodium would be two different types of elements. And just to give you some reference, the elements can be found in what we call the periodic table of elements. So this looks something like this, which you might have seen before. And essentially, this table lists all of the elements that we can find and that we know of. And there's about 100 in here. Okay, and so essentially what you can see is each of the elements is represented by a different symbol. So over here we have Na, which represents sodium, and what that's saying that for an atom of sodium, if you want to represent that by writing, you'd write Na. If you have an atom of oxygen, on the other hand, that's represented by the letter O. And we'll look into these other numbers and the periodic table in a bit more detail, but essentially for now, what we need to know is that you can have different types of elements, and they're represented by their letters and their symbols like that. And so when it comes to chemistry, we're particularly interested in what happens when we can react these different elements together. When you take element A, for example, so let's A, and we react it with element B, you might do a reaction like this, and what you can end up forming is what we call a compound. Okay, so when you react two or more different elements together, you can end up getting a compound, which is a new substance essentially, and you've created a new substance from your two elements. Now that new substance you create is not in itself an element because it's just a combination of the earlier elements. So let's actually have a look at what that might look like. So you might have an atom of oxygen, or the element oxygen, and you might react that with some carbon. And let's say you react your oxygen like this, and it comes in a pair, and you react it together and you form a compound called carbon dioxide. Okay, so this is an example of a chemical reaction. And in chemical reaction, a few points that you do need to know. Typically in a chemical reaction, you always end up with a new substance, and you also always end up with, well, often you end up with some kind of detectable energy change. Okay, so those are chemical reactions, and essentially what we're saying is that if we react the correct amount of oxygen with the correct amount of carbon, we can form this new compound, carbon dioxide, and that will basically be a combination of both carbon and oxygen. And so when we write the chemical symbol for carbon dioxide, you can see the carbons comes from there, the oxygen comes from there, and we combine them together, and this is what we call a compound. And if you want to separate a compound out, so if you wanted to go the other way, you want to do reverse this back to carbon, this one back to oxygen, then you would also need to do a chemical reaction to actually have that happen. Okay, so either way, you need a chemical reaction, even if you're trying to separate a compound into its elements. And so kind of the diagram we've got here is quite a crude representation, and we want to be able to represent chemical reactions in a more simpler way and a more consistent standard. And so one way we can do that is by using equations. So equations can be written in both word form and also in the form of the symbols. And so the symbols you can take straight from the periodic table, and the word form is obviously just a word. So for example here, we could write oxygen plus carbon gives us carbon dioxide. So that's one way we could write out that chemical reaction with that word equation there. We could do the same thing, but in terms of the symbols. So we should know the symbol for oxygen now. It's O2, and you can see it's O2 because if you go over here, you have your oxygen over here. And generally, oxygen comes as a pair like this, but don't worry about this too much if you don't quite understand why there's a 2. For now, we'll just put O2 plus the element carbon, and that comes out to carbon dioxide. And what you'll notice here is that actually the numbers of the elements need to add up. So here we've got one atom of carbon and one atom of oxygen in a pair like this. So technically 2 atoms there, and so we get 1 atom of carbon here and 2 atoms of oxygen there. And we'll talk about balancing equations in a future video, but essentially what we do need to know is the basic concept of being able to write chemical reactions and equations like that. Okay, so let's have a go at some questions now. To wrap things up, see what you guys understood from the video. So question 1, which of the following are elements? We've got Mg, Zn and NaOH. So you should hopefully know that Mg and Zn are both elements, and they can be found in the periodic table. NaOH is an example of a compound, and you can tell that because you've got a capital followed by a lowercase letter. So this is one element essentially, and then you've got an element of oxygen, capital letter, and an element of hydrogen, another capital letter. Okay, So here we've got 3 different elements combined together to form a compound, so it's not an element. Question number 2 is the following a possible chemical reaction. So we've got Na plus Li, so sodium plus lithium goes to sodium plus lithium. And one thing that you do need to know about chemical reactions is that there's always a new substance being formed, at least one new substance. In this case, we don't have any new substances. It's the same substance we started with, so it's not a chemical reaction. So we'd say no. And the question number 3 then, true or false, chemical reactions always result in energy being released. Well, we should know that chemical reactions often result in a energy change that we can detect, but it might not be energy being released. It could actually be energy being stored instead. And so we'd actually say this is false. Okay, so hopefully you got those correct, and I'll see you guys in the next video.